Hi, my name is Trujillo.
I'm Daniel Pina.
Braxton Bolin.
Michael Ragland.
Brittany Kaysen.
And today we will be presenting our design alternatives presentation for the engineering building that was proposed to us by Tarleton State University, located in Stephenville, where we were tasked to design a university office that had different components of the building phase, such as structural foundation, transportation, water resources, and environmental. For the structural component, the objective is to design a structure that is capable of sustaining all of the design loads that are in accordance with the local standards and also in accordance with a lot of different other engineering standards, and also take into account the architectural design.
For the geotechnical component, the objective was to design a foundation that can support loads from the structure and also the transportation components. The engineer must take into the following into consideration: the design standards, the soil conditions, and foundation types.
The goal of the transportation component of the project is to design a parking lot that will support the typical vehicle loads of the faculty working at the new office building. Then the engineer must take into consideration the design standard types of pavements, and that the client prefers a PCC or a plain cement concrete pavement.
For the water resources aspect of the project, the goal is to control precipitation, runoff, and reduce the amount of contaminants in the excess water. The following contaminants must be considered: gutters, inlets, stormwater pipes, outlets, and LIDs, which will be discussed later.
For the environmental aspect, we had to take in the 800 milligrams per kilogram concentration of lead in the soil at the site and use a treatment system to reduce it to 400.
Our project deliverables were also separated into our separate phases of the project, and for the structural component, the client wants us to design slabs, beams, and columns, and create a variety of notes and layouts that the contractor can look at and decide on how to build the structure. Also, a cost estimate showing how much the structural component of the project will cost.
The project deliverables for the foundation part of the project are calculations for requirements of shallow and deep foundation types, foundation plan with location of foundation elements, drawings for detailed foundation elements, general notes for foundation construction, and the cost estimate and foundation inspection plan.
For the transportation section, the client requested the design of the pavement, thickness, joints, and steel reinforcements, a whole set of design drawings for the parking lot, and also a cost estimate.
For the water resources, the client requested a development of a stormwater system and treatment train with the appropriate drawing and specifications of the system with recommended maintenance plans, and as well as a cost benefit analysis for the traditional system versus the LID alternate system.
The client has asked the environmental aspect to create a treatment and management system for the lead concentration, as well as a cost estimation of that system.
Now we will go over the design alternatives for each of the different sections of the project. For the structural component, there are three main components that come into the structural, which are the slabs that support the weight of the walls and the ceilings, and the beams and the columns. For the slabs, there are one-way slabs on beams, which only are supported on one or on two different sides by beams. One-way joist slabs that are supported by a multitude of rigid beams under the existing slab, and this is one of the most commonly used ones in offices. The waffle slab, which is typically used in locations where they want to have that space kind of as an aesthetic design to put things in between the waffles, I guess you could call them. The flat plates, which typically deflect more because as they sound, they're flat plates, and it's literally only supported by the columns. the two-way slabs on beams, which are typically some of the most safer, but also one of the more expensive ones because of all the framework that comes into play whenever you design a slab that's supported on all four sides. For the beams, we took into consideration two different ones, the steel and the reinforced concrete. And we really only selected the reinforced concrete because the architect already spec'd in reinforced concrete. For the structural columns, we took into consideration both the tie columns and the spiral columns that both serve the same purpose as columns. And there are some benefits over another, which we talked about in the decision matrix. For the slabs, we can see that the one-way slabs and the one-way joist slabs are the ones that have the highest scores based on firm experience that we have. Previous projects that we have worked on the workability of the project, such as how easy it is for the construction crew to go out there and build it, the aesthetics, and the design duration, in that how long it would take us to design the project. And yeah, and the beams were graded on the same way and the columns the same way as well. And we were going to use one-way slab beams, one-way joist slabs, steel or reinforced concrete beams, and for the columns, both the tied and the spiral columns are going to be taken into consideration.
We decided to view 4 designs for the foundation. The individual footing is good for column-supported loads from the structure, and strip footing is similar to the individual footing as it is a shallow foundation, but it supports loads from walls instead of columns. Mat foundations are more for larger loads than most other shallow foundations, and friction piles are a deep foundation that uses soil friction to support loads. From the decision matrix, we compared the 4 designs using firm experience, cost, ease of construction, aesthetics, and design duration, and the individual footing and friction pile came out on top.
The following 5 types of pavements were evaluated or researched for the parking lot design. These include concrete, asphalt, gravel, permeable pavers, and plastic pavers. Plastic pavers can have an infill of grass or gravel. Concrete will require the design of longitudinal and transverse joints and steel reinforcements. And also there are treatments available for subgrades, such as lime treatments, and also supplementary cementitious material that will decrease the thickness of the concrete and decrease the total cost. The pavement types were evaluated in the following order, according to their cost, maintenance, durability, aesthetics, permeability, and firm experience. Concrete will have a higher initial cost than asphalt, but will prove to be more cost-effective in the long run due to the less maintenance it requires, whereas asphalt will require the infill of potholes. Concrete also scored the highest in durability, aesthetics, and firm experience, making it the baseline design, and asphalt scored second, making it the second alternative.
For the first alternative we're going to talk about for water resources is a traditional gray stormwater system. The components of this are gutters, which transport water down streets or ditches to the closest inlet, where the inlet is the entry point of the stormwater sewer. Once the water enters the inlet, the water is conveyed to the stormwater pipes. The stormwater pipes convey the water to the closest surface water body, and there it is discharged through an outlet. The next alternative we're going to talk about are low impact development, or LID stormwater systems. There are many different LID methods. The first one we're going to talk about is a green roof. This is a vegetation layer grown on a rooftop. Green roofs capture water when it rains, slowly releasing the water through evaporation and plant use. The next LID method is bioretention ponds. This is a shallow basin used to slow and treat on-site surface runoff. The water is directed to the basin and then moved through the system where it is treated by numerous processes. The water is allowed to infiltrate native soil or directed to a nearby stormwater drain or receiving waters. Another alternative is permeable pavements. This is a specific type of pavement with high porosity that allows rainwater to pass through it and infiltrate the ground below. The last alternative is permeable or flow-through planters. Flow-through planters are structures landscape that collect stormwater and filter out pollutants of water that moves through the vegetation, growing mediums, and gravel. Here is the decision matrix that was used. As you can see, the gray systems has the highest total, which makes this the baseline design. The second and third highest is the bower retention pond and flow through planter. These will be the combination of these two will be used for the alternate method.
For our treatment system, we looked into vitrification, electrokinetics, and solidification. We analyzed it through costs, benefits, disadvantages, and its time. The electrokinetics, with its cost being the cheapest and the least amount of disadvantages, it has been chosen as the main treatment system. As for our management system, looked into plants that can absorb lead through the soil, through their roots. Looked into sunflowers, cabbage, and ragweed, with sunflowers and ragweeds being the cheaper options. They were the top two. However, ragweed is an allergen, so sunflowers did have more of an advantage over. That'll be our choice of management.
So we also created a timeline showing events that we want to have completed by the following semester, and ultimately it shows that we want to have all of our design and our report completed by April. And here are some of our references. Thank you. If you have any questions, you can contact us through our email.